This video is for educational purposes. All materials used are intended for that purpose. Have you ever wondered about the solar activity of our sun? Today we're diving into a discovery that reshapes how we understand our yellow star. The sun is located about 93 million miles away from planet Earth. The sun's light actually takes about 8 minutes and 19 seconds to reach us. The sun is about 109 times wider than planet Earth, meaning about 1 million Earths could fit inside our sun. It's made of very hot gases, mostly hydrogen and helium. The hottest part of the sun reaches about 27 million degrees Fahrenheit. A human would succumb to lethal solar radiation and heat about 4 million miles from the sun. However, approximately 489,000 people die each year from heat-related illnesses on planet Earth. That number has little hope of changing soon, because NASA has revealed something surprising, something that challenges decades of assumptions. Since 2008, the sun has been waking up. After years of calm, it's becoming more active. This ramp-up in solar activity has enormous implications for planet Earth. It has a direct effect on our technology and our future plans in space. For most of human history, the sun looked steady and unchanging. However, scientists actually know better. Because the sun pulses with energy in repeating cycles, it rises and falls in activity roughly every 11 years. These cycles determine how often we see a tick-up in solar activity. The sunspots, solar flares, and massive eruptions of charged particles are part of these solar cycles. But beyond these familiar cycles, the sun also experiences long-term trends that can stretch across decades. From the early 1980s all the way to 2008, the solar activity of the sun steadily declined. Year after year, the sun grew quieter. Sunspots faded. Solar storms weakened. By the mid-2000s, scientists were recording the lowest solar activity levels in modern history. Many experts believed the sun was entering a prolonged period of calm, possibly similar to the Maunder minimum of the 1600s. This Maunder minimum is when solar activity dropped so low it coincided with colder temperatures on Earth. But then something unexpected happened. Instead of continuing its downward trend, the sun suddenly began to ramp up. Activity increased. Sunspots returned. Solar flares grew stronger. Researchers warn that the sun's renewed energy could lead to more frequent and intense space weather events. These events aren't just cosmic fireworks. They're powerful, unpredictable, and capable of affecting life here on Earth. Solar storms can disrupt GPS signals, interfere with radio communications, and even damage satellites. Stronger eruptions, known as coronal mass ejections, can send massive clouds of charged particles hurtling toward Earth. This could potentially overwhelm power grids and expose astronauts to dangerous radiation. For spacecraft traveling beyond Earth's protective magnetic field, these storms can be life-threatening. This is why NASA pays such close attention to the sun. To monitor the sun's behavior, NASA relies on a fleet of spacecraft positioned throughout the solar system. Missions like the Advanced Composition Explorer and the WIND spacecraft sit in strategic locations in space. They are located where they can detect incoming solar particles and measure changes in the solar wind. These spacecraft act like early warning systems, giving scientists crucial data to predict solar activity. They also predict how the sun's activity can affect Earth and future missions. This early warning system is crucial because when dealing with space, time really matters. As NASA prepares to send astronauts deeper into space, understanding the sun's behavior becomes even more important. Outside Earth's magnetic shield, astronauts are far more vulnerable to solar radiation. A single unexpected solar storm could have tragic consequences and jeopardize an entire mission. This renewed solar activity reminds us of something profound. Our sun is not a quiet, gentle star. It is alive, dangerous, dynamic, and constantly changing. Every flare, every eruption, every shift in its magnetic field is a reminder that our solar system is an active place. Humanity is only beginning to understand its rhythms. So, as we continue exploring the Moon, Mars, and beyond, staying attuned to the Sun's behavior isn't just scientific curiosity. It's essential for the future of human space exploration. Keep your eyes on the skies, stay curious, and stay informed. The Sun is speaking again, and we're finally starting to listen. We'd like to thank you for joining us on this space journey. If you enjoyed this deep dive into solar science, please make sure to like, share, and subscribe. Thank you for watching Odyssey, Origins of Reality.